You know, when we think about digital security, our minds usually jump straight to secrecy, right? Keeping our data safe from prying eyes. But that's really only half the battle. There's another question, one that's just as important, that we absolutely have to answer.
What if the message gets through, but it's not the original message? How can you really trust that the file you just downloaded or the email you just got hasn't been tweaked, even by a single comma? This isn't about secrecy anymore. This is about integrity, and it's the absolute foundation of trust online.
So, how do we solve this? Well, we need a way to prove our data is exactly as it was when it left the sender. Our first line of defense is this incredible concept called hashing. Think of it as a unique, one-of-a-kind digital fingerprint for your data.
So, what is hashing, really? Well, imagine you have a machine that can take any piece of data, a single word, a huge photo, an entire movie, doesn't matter, and it crunches it down into a short, fixed-length string of characters. That string is called a hash. And here's the crucial part. It's a one-way street. You can't take the hash and work backward to get the original data. It's purely for identification.
The real beauty here is that this works on anything and everything. An email, a software update, a legal contract. Each and every one can be given its own unique digital fingerprint. It's like a mathematical guarantee of what it is, right now, in this exact moment.
Okay, to really wrap our heads around this, let's visualize it. Imagine we're in this digital space, and we've got this special machine, let's call it a 7D prism, that can see the very soul of data and turn it into pure light.
So here's how it works. First, you take your original data. Let's picture it as this perfectly clear, transparent document. Then you feed that document into our hash machine, this shimmering, multi-dimensional prism. The prism takes the data, refracts its very essence, and projects this unique, compact string of glowing light code. And that right there, that's your hash. That's the fingerprint.
Now, this brings us to the absolute most critical part of this whole idea. For this to work, if even a single pixel or comma in that original data changes, the fingerprint has to change completely. If it doesn't, the trust is broken and the whole system is totally useless.
And this slide, wow, this really shows you the sheer power of that change. Look, all we did was alter a single character from 2 p.m. to 3 p.m. Now look at the hash. It's not just a little different, it's a completely new, totally unrecognizable string of characters. This is called the avalanche effect, and it's what makes this so powerful. You can't sneak in a tiny secret change. Any modification, no matter how small, creates a totally different fingerprint, and bam, the trust is instantly broken.
Okay, so hashing is fantastic, right? It tells us with absolute certainty if our data has been meddled with, but that only solves half the problem. We know if it was changed, but we don't know who it's from. How can we be sure who actually sent the message in the first place?
This is where we level up. We need to take our digital fingerprint and combine it with an unforgeable lock. And that brings us to our next brilliant idea, the digital signature. It builds directly on everything we just learned.
A digital signature is just pure genius. It works like this. You take the hash we just created, that digital fingerprint, and you encrypt it using something called a private key. Now, this key is part of a special matched pair, a private key that only you have, and a public key that you can share with the whole world. That pairing is the secret sauce to proving who you are.
So, let's walk through it. Step 1. You run your message through that 7D prism to get its unique hash. Step 2. You take that hash and you lock it using your private key, the one that only you have access to. And finally, step 3. You attach this newly encrypted hash to the original message. This whole package acts like a modern, unforgeable 7D wax seal.
And this simple process gives us 3 incredibly powerful guarantees. First, authenticity. Because only your private key could have created that signature, we know for a fact it came from you. Second, integrity. The receiver uses your public key to unlock the signature, they recalculate the hash of the message themselves, and if those 2 hashes match, they know the message is untouched. And third, something called non-repudiation. You can't later deny sending it because you are the only person on Earth with the private key that could have sealed it.
So when you put it all together, this combination is the bedrock of digital trust. The hash guarantees the message hasn't been altered, and the signature, locked with a private key, guarantees who sent it. It is the ultimate proof that a message is both authentic and completely unaltered.
And this leaves us with a bigger, more philosophical question, doesn't it? These tools give us mathematical certainty, which is amazing.
But as we move deeper into an age of AI-generated content and flawless digital copies, these ideas, hashing and digital signatures, become more than just technical tools. They become a foundation for how we establish truth and authenticity in a world where, frankly, seeing is no longer believing.